Okay, kids, hello, and welcome to lessons 9 and 10 in Module 3. Let's get into this. This is going to be great. Good stuff happening in these two lessons. Why am I combining them? Because it's really just more of the same thing. We're adding fractions. We're making like units. The only difference is lesson 10, you're going to have larger sums up to and greater than 2. So they're still pretty small, but getting us used to the procedure. Really important things that you would want to do, taking notes. Keep your notebook handy because this is all very, very important. It's going to come up again and again and again. A scale factor, a very important number that you will multiply with, although you shouldn't end your sentence with a preposition, but that's not a sentence. A scale factor is a factor. A factor is a number you multiply. Scale means I'm going to change the scale of the digits in the fraction without changing the equivalency of the fraction. So, fancy words. What do you mean? Well, what I mean is I'm going to take this problem, for example, 1/2 plus 2/3. And because they have different denominators, I have to make them the same. So we're not going to use an area model. We're going to move away from the area model. Don't tell the kids who are watching lessons 6, 7, and 8 that they don't have to use the area model forever. Yeah, we're going to just drop that off. It takes a lot of time. It takes up a lot of space. And the idea is if you understand what the area model is showing you, then mathematically you should be able to just like slide right into this skill. So the scale factor is, and I've mentioned it in a few other videos, the number you're going to multiply by in order to get your common denominator. So here we've been doing 2 times 3. I'm just going to multiply these. These become my factors. 2 times 3 is 6. Bam, there's my common denominator. So the 3/3 is the scale factor. So 1/2 times 3/3 will give you 3/6. This is the scale factor. But it's a different scale factor for this fraction. 2/3 would be multiplied by 2/2 in order to get the 6ths. It's very important that you have this common denominator. So it's like I have to do whatever I can to get 6ths. And so for one, it's 3/3. And for another, it's 2/2. Now, as we get into increasingly larger problems, I'm going to say, use this strategy to find the lowest common denominator. It's skip counting by this number. So that, 6 just happens to be my lowest common denominator for 2 and 3, but it won't always. Like in lessons 5, 6, I think, they keep giving you numbers like 4 and 6, 4 and 6. And if you multiply, you'll get 24. But the lowest common denominator is 12. And so I don't want you to have to go using 24 all the time just because you're used to multiplying these. I want you to use the lowest common denominator. This is going to be your strategy for getting the lowest common denominator. Skip count. So you're going to have your times 1, times 2, times 3. And for each one, this is your scale factor. So that's where I got the 2/2. Okay, for the thirds, and this is where I got the 3/3 for the halves. So you just kind of connect that. Now, more important stuff. A fraction is a ratio. It's a relationship between the top and the bottom numbers, the numerator and the denominator, the fancy words. So if you change either the top or the bottom, you must also change the other. Because if you only change one, you're messing up the relationship between the top and the bottom. So you have to change them at the same rate, always. That's how you make equivalents. More samples. So this, when you finally come down here, it's all the same, 1/2 plus 2/3. Here are my equivalent fractions, 3/6 plus 4/6, which I just got up here, which makes 7/6, which is an improper fraction. So you take 6 into 7 one full time, or 6/6 is equal to 1 with 1 left over. There are more problems that are samples in the teacher's edition, which you would do before you start the lesson. For example, 5/9 plus 5/6. Okay, ninths and sixths are not like units. So you line them up, do your skip counting. find a number that they have in common. They have 18 in common. How do you get it? Use a scale factor to get it. 9 times 2 is 18, so 2/2 is your scale factor. 6 times 3 is 18, so 3 is your scale factor. So this lesson is all about finding that scale factor and using it so that we can make like units numerically. Fancy word for saying just with numbers and not with the area model. 10 plus 15 is 25. This is an improper fraction. This is too big. So flip it so that you've got 18/18 as your 1, and then find the difference between these two. As one of my students said today, just subtract. And I was like, yep, that's what your numerator is going to be out of 18. Finally, my students are so amazing. There we go. What if you have 3 add-ins? Now, we've had this once before when we had to do like 2 times 3/4 plus 6/8. But now they're all different. So you want to find a common denominator that is low. You don't want to have to multiply these. It could potentially get really, really big. Just line them up, start skip counting. Times 1, times 2, times 3, and put your products all out until you find one that they have in common. The trick is finding the one that they have in common that is the lowest. Then change your fractions by using the scale factor so you can think about it instead of always having to write everything out. So if I need to get 12ths, 3 times what is 12? That's going to be my 4. So I'm thinking about 4/4. 4 times 2 is 8. That's where I get this. 4 times 3 is 12, so 3 times 1 is 3. 2 times 6 is 12, so 1 times 6 is 6. That's where I got these numbers. Now I add. I end up with another improper fraction. Again, our sums are going to be between 1 and 2 for many of these. 1 and 5/12 is your answer. Now, I also have the old way, and last year one of my students loved this way. She said, why don't we do this anymore? And I said, I don't know. They changed it all up for fancy math people. But when I was growing up, this would be how we would set it up. Okay, we would have 2/3 plus 1/4 plus 1/2, and it would be a setup in a vertical arrangement instead of horizontal. It does not matter. This is how they're going to do it in the book every time. But if you in your scratch paper want to write it in a vertical way so that you can show the equivalent next to it and put your scale factor over here, this can maybe help you organize your thoughts a little bit better. And I, of course, will never stop you from doing something that helps you organize your thoughts. Okay, so that is lesson 9. That's pretty much all that's important in there. And that took a long time, so we have to hurry up and get into the book. So we're going to make like units, and then we're going to add. First of all, 3/4. Oh, I almost started making an area model. Good heavens. So thinking about what 4 and 7 have in common, I would want to start skip counting. But you also know that you can multiply if you don't immediately think, oh, I don't think they have anything in common. So I'd have 7, 14, 21. None of these are multiples of 4, and so I'm starting to get out pretty far. And then I have 1, 2, 3, 4, and that's 7 times 4. So I know I need 28, and there's nothing lower. Okay, so these need to have the same units, and the scale factor is the other number, which makes it really easy. So since 7 is the scale factor for this one, it's 7/7. That's my scale factor, so 7 times 3 is 21. And since I had to multiply by 4, then my scale factor for this side is 4/4. So there's my 7 times 4 is 28, and 1 times 4 is 4. And I get 25, 28, and I'm done. And I always think about, can I simplify it? But I cannot simplify this one. 1/4 plus 9/8. Okay, always, always think about the lowest common denominator. 8 is a multiple of 4. The only fraction that needs to be changed here is the first fraction. Move the second one down without changing. Okay, I just need to make eighths out of fourths. How can I do that? I'm going to use 2. 4 times what is 8? 4 times 2 is 8. What you do on the bottom, you do on the top. I have 2 eighths plus 9 eighths, 9, 10, 11, 11 eighths. Don't leave it improper. 8, and then the difference between, so it's like a subtraction problem, 1 and 3 eighths. If you happen to use a different denominator like 16ths, then you'll have to do 4 times what is 16? 8 times what is 16? But why? I wouldn't want to make anything bigger if I didn't have to. What if you use 30 seconds? Can you use 30 seconds? Sure, but you're going to have to simplify when you're done because those answers will not give you this in simplest form. This is simplest form. Okay, 8 and 7. Ooh, this is a tough one. When they're that close, there's usually not going to be anything else that you can do except multiply them by each other. Remember, if this is the scale factor, I'm going to multiply it by the top as well because it's 7/7. So 7 times 3 is 21. Multiply these two because I'm using this as my scale factor. So I need to do 8 times 3 is 24. So my new fractions are 21/56 plus 24/56. Now I have a really big addition problem. Always start in the ones place in case you have to carry over, but they're giving us pretty easy answers. And 45/56. Always look at these and then think, can I simplify? Always. But you can't here, so we're just going to move on. But just think about it. 9 and 7, okay. Again, thinking about multiples of these. If you want to line them up, you can and skip count. I just want to tell you that there is nothing that they have in common. If I did 9, 18, 27, you won't have any multiples until you have 9 times 7, which is 63. So the idea is to line them up, skip count, and find something in common, but there is nothing in common until you get to 63. 7 is my scale factor for the first one. So 7 times 9 is 63, 7 times 4 is 28. 9 is my scale factor for the second one. So 7 times 9 is 63, and 4 times 9 is 36. And now I have my new fractions, and I need to add them. And again, very big numbers. Start here so that you can regroup. 8 plus 6 is 14. Carry the 1. 3, 4, 5, 6. 64 60/3 makes this just a little bit too big. Don't leave it like that. That's improper, even though there's only one extra. Next one. Got to move it up. 1/5 plus 2/3. Okay, the lowest common denominator. Well, if I multiply it, I'm going to get 15, and that's pretty low. So I have 15ths. My scale factor for this one is 3/3. 3 times 5 is 15, so 3 times 1 is 3. Use this one. 5 times 3 is 15, so 5 times 2 is 10. Add them together, 13/15. There's nothing I can do to simplify it. That is an easy one. And for this one, here they are, 4 and 6. Now you don't have to multiply and get 24 when 12 is lower. Let's prove it. 6, 12, multiples. 4, 8, 12. Ta-da! Lowest common denominator, right there. Use it. Don't make it bigger if you don't have to. How can I get from 4 to 12? What's my scale factor? 3. 4 times 3 is 12. 3 times 3 is 9. This is my new equivalent fraction. How do I get from 6 to 12? 2. 2 is my scale factor. 6 times 2 is 12, so 5 times 2 is 10. Always change both the top and the bottom at the same rate. so that you can keep that ratio the same. 12 fits into 19 one whole time with a difference of 7. And that's your answer. Zipping on, cruising, we're cruising to victory. 2/3 plus 1, 11th. When you have 11, that's always kind of a funny number because it's a prime number and there aren't any multiples or factors of it except 1 and 11. So I know I'm going to end up multiplying these and I will get 33. And what is my scale factor? Well, it's the other number. So it's 11 elevenths and 3/3. So this is going to be 11 times 2 for 22. And again, the ratio is still 2 to 3, or 2/3. 22 33rds. And then 11 times 3 is 33, and 1 times 3 is 3. 22 plus 3, 25. Another easy one. And then 3/4 plus 1 and 1/10. Ooh, fun. Okay, if you have a whole number, you can separate it out and just kind of keep it off to the side and just keep moving it down. But what we really need to consider is that these two have to have a common denominator before you can combine them or add them. So if you just kind of set your 1 aside, and then we're going to look for common denominators. Now, out of 4 and 10, I do not need to multiply and get 40 because 10 times 1 is 10, but 10 times 2 is 20. And 4 has 4, 8, 12, 16, 20. Bammo. And I knew that, but that's because I know my facts. You might not know your facts that easily, so skip count. And when you get 20, that's your LCD, lowest common denominator. Once you have 20ths, 4 times what is 20? 4 times 5 is 20. So if you change this on the bottom, you must change it at the same rate on the top. How did you get from 10 to 20? 10 times what is 20? 2. Whatever you do on the bottom, you do on the top. So my simplest form fractions I can now combine, and then this just becomes your final answer. Easy. Yay, you're gonna love these. It's just great. Okay, Whitney says that to add fractions with different denominators, you always have to multiply the denominators. Like 4 times 10. What? Every day. Oh, okay. You do not always have to multiply the denominators to find the common unit. Like I just did up here, I said you could multiply 4 times 10 and get 40. But why would you want to have 40ths when you can use 20ths? It'll be so much easier, and then you don't have to worry about simplifying. Always try to get the smallest unit. So Whitney says that you have to multiply. For example, 4 times 6 is 24. Show Whitney how she could have chosen a denominator smaller than 24, and then solve the problem. So use the skip count strategy. It's a tool for your math tool belt. Take your 2 denominators and skip count. Do times, well, this is already times 1, times 2, times 3, whatever you need. 6, 12, oh, lo and behold, 4, 8, 12. Once you have a common denominator, you can use it. You don't have to use 24. And why would you want to? Because it's so much bigger. So if I have 1/4 plus 1/6, I can change those to 12ths instead of 24ths. What is my scale factor? From 4 to 12, it's times 3. So 3/3. 3 times 4 is 12. 3 times 1 is 3. How do I get from 6 to 12? It's times 2. 2 is my scale factor. 6 times 2 is 12. 1 times 2 is 2. I can get 5/12ths the first time I add this instead of getting 10/24ths. if I end up with 10/24, those are both even numbers. I can't leave this. It's not in simplest form. That would force me to use a scale factor to scale down the size of my numbers. 10 divided by 2 is 5, and 24 divided by 2 is 12. Now I have the simplest form. So can you do this? Yes. Is it the lowest? No. So is there another way? Yes. Skip count, and then you will have the lowest form when you find the LCD. LCD. Okay, only 2 more problems. Doing great. Jackie brought 3/4 of a gallon of iced tea to the party. What party? Nobody told me about a party. Bill brought 7/8 of a gallon of iced tea to the same party. Ugh, they should have had lemonade, and why did they not spread out the drinks? Okay, so we've got a lot of iced tea. How much iced tea did Jackie and Bill bring to the party? So we've got 3/4 of a gallon and 7/8 of a gallon. Lots of iced tea. It's probably an adult party because kids don't really like that. So what do I need? Okay, I need a common denominator. Could I multiply these? I could. I would get 30 seconds, and that would be so much work. Why would I want to have 30 seconds when I have a lower common denominator option? If you skip count by 4 and 8, guess what? 4 times 2 is 8. The only fraction that needs to be adjusted is the first fraction. So just change this one by using a scale factor of 2. 4 times 2 is 8, so 3 times 2 is 6. And when you get your 6/8 plus 7/8, they match. So the only thing I have to do is just make these match. 6 plus 7 is 13/8, and then 8 goes into 13 one full time. Again, 8/8, and then the difference between 8 and 13 is your new numerator. 1 5/8 gallons of iced tea. Iced tea is your final answer. Okay? Not too bad.